Welcome to W.Media podcast, our exclusive series of panel discussions and interviews featuring the who's who of the global cloud and data center industry. This is your one stop destination for expert opinions and insights from movers and shakers and everyone that matters in the data center industry. Hello, Namaste Salam. I'm Deborah Grey and I serve as regional editor, South Asia and Middle East for W.Media. My co host for today's show is a keen industry watcher and expert, Daryl Dunbar, partner digital infrastructure at Internal Consulting Group. Hi, Daryl.
Hi, Deborah, and thanks for having me on the show. Excited to talk about this topic, sustainable energy, the sources, the drive that it's putting into the data center industry, and I think most importantly, how we stay away from, I'll say a nasty word, greenwashing.
That's true, Daryl. It's time the industry moved away from PR stunts and started walking the talk on sustainability. And to discuss this hot topic, we have with us today Ning, Senior Liquid Cooling Solutions Manager at Shenzhen Envicool Technology, Sandeep Dandekar, data center expert from India who has worked with some of the top international data center operators, and Timmy Fung, Senior Director, Data Center Capital Markets at JLL.
Great. But before we dive into our first segment, I guess a word from our sponsor.
This episode is brought to you by Sejori Week, where W.Media is bringing together data center operators, end users, architects, engineers, and experts from across Southeast Asia's most vibrant data center market. Sejori Week celebrates the cloud and data center ecosystem in Singapore, Johor, Riau Islands with seminars, site visits, networking events, and even a friendly round of dwarf golf. All this and more starting July 14. For more information, please visit www.sejoriweek.net.
Okay, let's jump right into our first segment, where we're going to take a closer look at how liquid cooling can help data centers achieve sustainability goals. Deborah.
Well, our first question is for Ning. Why is liquid cooling considered more environment friendly than other forms of cooling?
Okay. When talking about environment-friendly energy, carbon emission, and water usage are the top topics. And so when we compare liquid cooling with other forms of cooling, mainly conventional air cooling for environmental friendliness, there are three main points, including power consumption, water consumption, and refrigerant use. In a direct-to-chip liquid cooling system, the water temperature typically range from 40 to 50 degrees Celsius, which is relatively high compared to the air temperature required for air cooling systems, which is around 24 degrees Celsius. Therefore, this system can leverage natural cooling source more effectively without the need for a compressor, resulting in lower power consumption and reduced refrigerant usage, contributing to sustainability and lower carbon emissions. Additionally, when the ambient temperature at the project site is relatively low, external cold source like dry coolers can be utilized to significantly decrease water consumption. And that's my opinion.
Great, Ning, thanks. What do you think about that, Sandeep?
As we all know that data centers consume today already, as is a significant percentage of global electricity, as well as water consumption, about 2 or 3% of global electricity consumption, and a significant amount of water consumption. And we all know that with the increasing streams of data storage and data exchange that will come, AI workloads where the requirement will increase multifolds, this will further increase. Data centers also emit large amount of heat in the environment. And as I said, with the increasing demand with newer technologies, applications, it will further rise at a very high pace. So a multi-tiered or a multi-stream approach needs to be used to minimize the impact. Because ultimately, if there is Mother Earth, only then there is human. And if there is human, then there is data center. So Earth will not exist for data centers. It has to be other way around. Water is a shrinking precious thing, and we we all know. To make it worse, just like living beings, data also needs water to survive. To make the canvas more complex, I don't know how many people would have thought about this aspect, but we know that substations are targeted by cyber attacks. Similarly, there have been instances where water infrastructure has been target of cyber security. Large water infrastructure remains on their target list. So that also creates one more risk for data centers, because obviously if the water infrastructure is under attack, obviously livelihood of human beings and lives around becomes more important. But this also creates kind of a risk for data centers in case the water infrastructure is attacked or is disrupted. So on a broad basis, we can say that data center operators are faced with a considerable challenge related yet diverse. When we say liquid cooling, it is not the only thing that needs to be done from sustainability point of view or even from commercial sense of businesses, but this remains part of several others. Some of them, just to give the entire flavor, I will say the removal of heat comes later. Liquid cooling or any cooling is about removal of heat. At the same time, all the IT equipment OEMs are working to modify the technology, to upgrade the technology, to see that creation of heat itself is lower. That's number one, because you create less heat obviously load on removal is lesser. So that's one important. Capability of IT equipment being developed to work higher at ambient temperature. So if we required X temperature earlier, there is an attempt to see can we have equipment working at X plus 3, X plus 4 degrees ambient, which reduces the load on cooling. Improved heat removal efficiency of cooling methods using less or no water for cooling, migrating to renewable energy from fossil fuel. This is very, very important for all data centers. Reusing the heat pumped out that than rather simply dissipating it into atmosphere. You take out heat, and then if you don't have any alternate usage of that heat, then you end up just dissipating that into atmosphere. So number one, we waste that heat, and number two, we impact the environment. So several large players, depending upon the opportunity of environment, ambient, the delta of temperature, they are actually supplying this heat to nearby neighborhoods, towns, etc. In cooler places. Using free cooling from ambient, which means if you go to places where for a few months of a year you have substantially lower temperatures like 18 degrees, 10 degrees, even cooler, or you go to north of India, you get few months where ambient is lower. So we can use that free cooling from ambient. So these are various things. And two tremendous benefits of these newer and alternate method of technologies like chip cooling, immersion cooling, back of the rack cooling that we talk about, is to reduce the power consumption in heat removal and reducing consumption of water used in cooling of the DCs.
Great, thanks. I'm interested about the different types of cooling options. I mean, we've heard, or we're hearing now, lots of noise around immersion cooling, direct to chip, maybe even rear door heat exchangers. But what about those and others are available, and what are the key factors that drive the choice of which technology to put into your data center?
Actually, there are various types of liquid cooling options exists. You just mentioned, and with immersion and direct-to-chip liquid cooling being the most commonly discussed. And depending on the status of the coolant, both these options can also be categorized into two catalogs, single-phase and two-phase systems. And there are also other types like you mentioned, rear door heat exchanger and the water spray. And the choice of cooling method depends on factors such as heat density, energy efficiency, cost considerations, environmental impact, scalability, and flexibility. And the liquid is fundamentally more efficient at removing heat by up to 1,000 times. Typically, when the heat load exceeds 20 kilowatts per rack, air cooling struggles to efficiently remove heat, making liquid cooling a preferable option, especially when there are limitations on power usage effectiveness. We name it PUE. And when the heat load increased to 80 kilowatts or higher per rack, phase change liquid cooling may be more efficient. And additionally, in situations where the project sites lack water resources, a cooling tower is prohibited. In that case, a liquid cooling system can utilize an external cold source like a dry cooler, as I just mentioned, and this enables the production of warm temperature meeting temperature requirements of the server without the need for water.
Sandeep, what are your thoughts on this subject?
We have to use as less power as possible. We have to use as less water as possible, and we should dissipate as less heat as possible into the environment. So I think the whole thing is driven by these three things primarily. And I would say things that one needs to consider when you're introducing a liquid cooling or any type of alternate new age cooling into data centers is the heat capture, the plumbing that needs to be modified to suit the newer technology, the distribution, balancing capacity, risk mitigation. Every method has its own pluses and minuses. We will possibly go into details of that later during the course of this discussion. But these risks also need to be acknowledged and mitigated to an extent possible. And heat rejection is another thing. So these 6 or 7 parameters, I think, are extremely important to be considered when we are thinking of adopting a newer technology cooling.
Let me bring in Timmy Fung for a minute here. Liquid cooling also requires adequate provisions to set up necessary infrastructure in terms of architectural design and space. Now, this is different from the design for data centers that use traditional air cooling. Mr. Fung, are data center operators talking about this while looking for real estate?
So the short answer is yes. The main difference I have been noticing is the change of requirement from ceiling height to loading. So for the past decade, every project that we look into, we always look for good ceiling height so that we can fit in the air cooling, chiller, etc. But now, instead of looking at just the ceiling height, we still need a little bit of ceiling height, but the focus is really on the loading because equipment is getting a lot heavier, particularly when you talk about liquid cooling. Anything that do liquid cooling, I think roughly speaking, we need at least 20 kPa nowadays. And generally speaking, I think most industrial building cannot accommodate that. So I do believe that in the near future, we will be seeing a lot of new development tailoring for liquid cooling because the old data center is simply not suitable for it. And if we want to do a refurbishment on an old industrial building, never say never, but it's very, very difficult to actually get the work done. We have looked into a few projects and the old architecture for industrial building, it just doesn't fit today's technology. And not to mention that we are building the data center for next generation. And if you force an older building to convert into a data center with liquid cooling, there's just so many layer of mismatch that it doesn't look right. So I do imagine that in the near future, we have to do a lot of redevelopment to tailor the data center for liquid cooling.
So going back to you, Ning, what are some of the concerns around liquid cooling that are acting as deterrents to its adoption? I think a lot of people consider it's possibly more expensive, higher capex, fear of it leaking, corrosion, pressure buildups, those sort of things.
The introduce of water into the data center has raised many concerns, and we actually have talked with our customers from various industries, like server, data center, energy storage system, and the most common concerns are reliability and the TCO. And as the fluid flows through every components in the liquid cooling system, a potential risks caused by like material incompatibility, including chemical corrosion, bacteria, and contaminants may lead to water leakage and a decline of thermal performance, causing damage to the server. And on the other hand, based on our calculation and the data from some white papers, the capex for direct-to-chip liquid cooling is approximately 1.5 times higher compared to air cooling, while for immersion cooling, it's around 2 times higher. And consequently, some customers are hesitant to adopt liquid cooling. Thus, you can notice that liquid cooling data centers are still only a small fraction in this industry, primarily utilized in scenarios where air cooling is insufficient, such as in HPC.
What do you think about that, Sandeep?
These are all new technologies. These are not new methods. Those are evolving. So obviously there is a curve of maturity of a technology. These technologies will improve. The teething problems, little rough edges will get rounded off. Then it will pick up volume. When you build volumes, your costs come down. At the same time, the education and the comfort of more and more users will evolve, because obviously it's a two-way process. More the technology improves, more the users are able to see use cases, the more confidence they get. So it's a part of education on the user side. So if we look at immersion cooling, the challenges are it requires hardware to be modified, because as we know, hardware is literally dipped into the tanks. It is nothing but literally giving a continuous bath of cooling liquids to your hardware. So to withstand the submersion of fluid, the hardware has to be modified. Vendors may choose to nullify service agreements for equipment. It's again, your customer, depending upon what is the type of data center. If it is a dedicated data center to any hyperscaler or large technology player who are already well aware of these technologies, are well exposed, they are in fact driving these changes themselves. But if you look at small enterprise, maybe retail customers, they may not be still that confident because of lack of knowledge or lack of required SME space. So they may have concerns. Your service level agreements may come into rediscussion. So all that may happen because of the hardware. So when we compare cost, the total capex tag of an immersion system compared to any aisle containment or conventional brick and mortar cooling methods are high. They must include all individual cost components, like uh, for facility infrastructure, as I said, to achieve required plumbing, to achieve required modification in the buildings itself. So there is some amount of re-engineering required in the existing. If we are thinking of retrofitting, it is very difficult. If we are talking about new facilities, then a different engineering is required, right from core and shell into MEP to your IT infra. The space aspect, an immersion system takes up more space in the data center floor, because obviously you have to place those tanks, you have to arrange for the liquid flows in and out. So that is one aspect. Nobody in data center wants to sacrifice space, because every square inch today comes at a premium price, particularly in metros. Land is high, cost of build is high. So nobody would like to, everybody wants to optimize the space, right? So this is one major aspect to look at trade-off. Leaks and spills are a concern, though most of these leaks will not really cause an issue for IT infrastructure, because these are all inert liquids. But they do cause some other things. They will cause loss of cooling in the system, which will result into assets getting heated up, or your components getting heated up, which may crash the cooling system. So these are things. Weight also is one more thing. You have storage tanks which weigh heavy. So your core and shell structures have to be designed to handle those additional loads. So these are some of the things that quickly come to my mind for the immersion cooling. In the rear rack also, you have issues like more air exchanges are required, because each server rack requires its own air exchange. You have to install and maintain more exchanges than you would do for a crack system, which is a conventional system. Lack of backups is another aspect that I can think of. In most cases, each rack that is cooled by a rear exchanger only has one exchanger. If that exchanger fails, the rack may quickly overheat. And crack systems are less prone to this type of a failure because they have multiple air exchanges. So that is, every data center would like to have redundancy, backup. Uptime is very critical. Service level agreements are very stringent. So anything that increases possibility of a failure is a big red flag for any data center. So this is one aspect. The leakage risk that we talked about exists, the environmental impact. Most of these fluids are not environment friendly. So they kind of create, though they reduce water consumption, which is a great help to environment, they themselves may not be very environment friendly. So in case of leakage, there could be a pollution or any other sustainable issues. And one very important thing needs to be noted in case of direct to chip cooling is the uncooled components, which means this direct to chip system only cools the major heat source. It does not cool the entire system, the entire asset. So let's say hard disk, it may remain at a higher temperature. That leaves an open risk for other parts to overheat and possibly be risk prone to failures.
My question's for Ning then. What can be done to make liquid cooling more popular, less expensive, and easier to adopt?
Actually, as a high efficient cooling solution, and switching from air conditioning to liquid cooling reduces OPEX by more than 40%. Thus, in order to make liquid cooling less expensive, the key point is to reduce the CapEx, which means to reduce the cost of the products and the installation. And in that case, standardization, modularization, and the prefabrication of the products are essential. Some companies and organizations have worked on these things, like specifications of UQD from OCP. It has defined the interface dimensions and the methods of both parts of the quick disconnector, enabling the interchangeability among different QD vendors. Thus, it can make the selection of QD simpler and cheaper. And moreover, numerous specifications for every critical components of liquid cooling system have either been released or are currently under development. Through these collective efforts, data center operators can achieve highly efficient liquid cooled data center with reduced costs and simplified designs.
Correct. So I think it's a question of time, and both if the service providers, technology solution providers, and the data center operators, if both are keen, they work in collaboration, the time frame of this becoming more feasible can be squeezed. So I think onus is on both sides, technology providers, solution providers, as well as on the data centers, in the interest of sustainability, that they work together in synchronization rather than putting an onus on the other side. What will happen is, as the technology evolves, it will become more mature. It will some of the risk areas will get eliminated. Some will become much more diluted than they stand today, and that will encourage more service providers to go for adoption. The more the adoption, the more volumes, the cost will go down. So that will also go in favor of adoption.
Daryl, I'm curious, industry expert yourself, you're a keen industry watcher. What are your thoughts on this subject?
Well, I think that as Ning pointed out, and we've talked about a bit, liquid cooling is inevitable. We're reaching the types of densities in data centers that air is simply going to struggle to remove the heat in an efficient manner. And we've touched on a couple of the barriers. Most of those are sort of fear, uncertainty, and doubt on the part of the people who are looking to implement. And I think we'll see. We'll definitely be seeing liquid cooling coming into the data center, maybe initially in some halfway technology or gateway technology like rear door heat exchangers, but I think direct to chip and then ultimately immersion cooling has massive, massive benefits. But we also need manufacturers of the servers and the chipsets to certify their equipment to be immersed. Now, it actually, there's no harm in putting servers in this non-conductive liquid. You can drop your phone in there, reach in after it, everything will be fine. People just need to get over the FUD, as I said earlier.
I'm also psyched about that whole data center they're building under the sea. I think somewhere in the South China Sea. I don't know how much that helps or if that can even be considered liquid cooling. What are your views on that?
Well, we've seen a couple of experiments. Keppel's doing one data center built on a barge coupled to the ocean for cooling. We saw Microsoft sink a data center under the ocean. And again, it's not liquid cooling within the data hall itself. It's actually still air cooled, but it's coupled to the ocean for the thermocoupling to remove that heat. And fascinatingly, when Microsoft did it, they put an identical data center on land, and they found that the total time to failures for equipment inside the submerged data center was less than half that frequent as the one on the land. But I actually think that has nothing to do with the liquid. I think it has everything to do with no one being able to get into the data center.
Nice. Let's move on.
Well, let's move on, but because we've got a great start, but I think we need to have another word from one of our sponsors.
That's right. Can't have an episode without them. This episode is brought to you by Japan Digital Infrastructure Week, where W.Media gives you a chance to explore Japan's thriving data center market and interact with the creme de la creme of the data center operators, industry experts, and veterans, and hear them as they share their technological insights and wisdom. For more details, visit www.digitalinfraweek.com/Japan.
Okay, let's dive right back into this great conversation. In our next segment, we're going to talk about smarter design and how it can play a role in helping data centers achieve sustainability goals. I'll kick off with the first question. What are some of the most effective ways in which designing data centers differently can help achieve sustainability goals?
So typically, core and shell you design today for the conventional cooling system mostly. And there are certain areas maybe the leading providers are providing in their data center for alternate method of cooling. As this technology will become more popular, it will start acquiring more percentage of space of data center than today, which means if let's say there is X square foot of area, X megawatt, maybe 10% of that X by 10, X by 5 today is dedicated for this cooling design. Time has to come when half of the building, the whole building will be designed according to these technologies. It may also happen that out of the three, some areas may have technology A, some will have technology B, some floors in case of vertical data centers, as we are mostly seeing them in India, these are vertical. So some floors could be direct to chip cooling, some of them could be immersion cooling, and engineering completely will depend upon that. As we said, engineering and execution will be siloed into a few areas. One is civil construction, core and shell, where you will have to provide enough space and load capacity to hold these tanks, hold these modified racks, allow the additional flow mechanism, whether it is pipes, whether it is airflow, whether it is putting up fans, liquid tanks, all that. So right from core and shell, even selection of equipment will change accordingly. Do you need a crack? How many you need? Their capacities will change. So all the equipment selection, right from let's say your DGs to chillers to UPS, may have in a way or the other an implication of what method we are selecting.
But are these designs difficult or expensive to build or implement, Mr. Dandekar? What stops data center operators from choosing these designs?
I don't think anything is stopping. It's a new change. It is still propagating. Everybody is very curious and very keen to adopt them. It's just that we need to see the critical volume and the critical enthusiasm levels, the threshold being beaten. Like I said, more customers show keenness, more operators will be willing to do that. I think we are at a threshold where data center operators are thinking, should I do it? Should I put in more capex? Will there be a taker for it? That's it. So I think it is more of a synchronization coming together, like I said, in the interest of sustainability, in the interest of environment, that I think customers have to come forward and give more confidence to the operators that yes, it matters to us. We are keen. We will give preference to that operator who is showing more proactiveness, more enthusiasm to do this. And that's how I think it is. It is a psychological threshold. It is a risk threshold, and the technology will mature. Like we said, the costs will come down, and eventually, I think in 3 to 4 years, if we are talking about 100 kilowatt per rack and even exceeding that with the GPUs and AI, I don't think it is going to remain a matter of choice or anybody will afford to be a lagger. Everybody, I think in 24 months of horizon, we will find a very rapid adoption of these technologies.
We're also seeing an increase in instances where older commercial facilities are being repurposed or retrofitted and turned into data centers. What kind of design changes can be implemented here to achieve sustainability goals? Ning?
And there have been some solutions and the products that are suitable for retrofitting and existing data centers to achieve sustainability. Measures such as optimizing airflow management, upgrading to more energy efficient equipment, and implementing intelligent cooling strategies like AI and AI controller, and can yield significant energy savings and reduce environmental impact. And retrofitting existing data centers with modern technologies and implementing best practices in energy management can help enhance operational efficiency and prolong the lifespan of existing facility. For a conventional air cooling data center, separate cold and hot aisle design, free cooling technology can maximize its energy efficiency. And there are also products like liquid to air CDU, and that can help transfer the data center to liquid cooling without requiring extensive updates to the infrastructure.
Also, I mean, if you go by what the United Nations says about sustainability, there are 17 sustainability development goals. And sometimes I wonder if we are being just too myopic when we, stick to things like PUE. What do you think about that?
Oh, don't get me started on PUE. It's the most, it's probably the most popular reported power use efficiency, the most reported statistic out there for data centers, but it is easy to game PUE. It is really not a very clear measure of the efficiency of a data center. For one, if the data center isn't fully loaded or close to loaded, it skews the PUE number. We have design PUE versus operational PUE. It depends on where we put certain pieces of equipment and where we put the meter as to how we measure it. So I think we have to look at more factors in a data center. I think we need to look at the amount of carbon that is emitted, but also, and one of the things that I find really interesting when we talk about repurposing existing facilities is the amount of embedded carbon that exists within an existing facility. I'm not pouring new concrete. I'm not generating new carbon leaching facilities. I'm actually taking over something that's already there. That this is something we should look at, embedded carbon. We should be looking at the other measures, water use efficiency in addition to power use efficiency. One of the worst kept secrets in the data center industry is that we evaporate liters and liters, tons and tons of water every day to cool a facility. Closed loop cooling systems, number of things that we could look at. I agree. I think even at 17, we're being a bit myopic in what we're looking when we're judging sustainability. I'd like to bring Timmy Fung in to weigh on this as well. We're talking about upgrading existing data center facilities, but actually, what about modifying or repurposing older commercial facilities into data centers? And what kind of concerns are the data center operators raising about sustainability when it comes to choosing such facilities?
So I have been discussing with a few parties that they actually don't want to tear down an old industrial building because of sustainability factor. When you destroy an old building to create a new one, there's actually a lot of carbon footprint in this process. Even though you are going to build a new building that is suitable for, let's say, the next 2 or 3 decades, the fact that you are destroying old projects and using new material to build it, it just create a lot of industrial waste. And some groups, because of this reason, decide to maintain an old industrial building and decide not to do a redevelopment. So it is a factor to consider. But again, going back to what I discussed earlier, the the concern is really can the old building fit the use for the next generation data center? It will has a lot of mismatch in terms of loading, cooling, ceiling height. Even the superstructure might not be suitable. But because of the sustainability factor, I do believe that some operator will decide not to do redevelopment just to reduce the carbon footprint.
Timmy Fung, I also have a question for you. Could you tell us which are some of the markets where you are seeing a more vociferous push for greater commitment to sustainability?
So my focus is in Asia, and I think overall the market is very hard for most country, Japan, Korea, Malaysia, Jakarta, and but unfortunately, all this very hard market, it's very hard to get green power. So when you talk about ESG and how to make the data center green, a few groups start to talk about going into the likes of Thailand, or Philippines, or Vietnam, where they can secure a lot of green power. Well, Malaysia has a lot of green power as well. So green power also become a very important factor of where people wants to be. And if we cannot deliver the green power for this operator, their clients just don't like to be there. For example, I have a discussion with a international bank that they can only be in data center and the groups who only ambition that they will be net zero by 2050. If they don't have such a plan, an active plan and active procedure to reduce the carbon footprint, this bank simply will not select them as one of the colocation user provider.
So, Daryl, I was wondering, AI has been vilified so much in pop culture. Which is the one movie you hold as like the biggest villain in villainizing AI?
Oh wow, that's a great question. I hadn't really thought about it. Maybe The Matrix jumps out. You could do that. You could look at Terminator. You know, there's so many movies where we've created this artificial intelligence that has overthrown humans and taken over the planet. It's a pretty bad view of AI. I think it's a lot more helpful than that.
Well, with that, let's jump into the third segment on how artificial intelligence can help us achieve sustainability goals. Ning, I have a question for you. How do you think AI can help with predictive analysis and intelligent power usage?
In a traditional data center, operating parameters are typically set as constants based on standard data, resulting in a significant energy wastage. In contrast, an intelligent data center equipped with an AI controller can collect operational parameters from sensors, analyze data center performance across a wide range of settings, and determine the optimal control point for maximum operational efficiency. And this enables automatic dynamic adjustments to match fluctuations in demands and optimize energy efficiency throughout the data center infrastructure. Moreover, it can also forecast the future demands based on historical data, allowing data center operators to optimize capacity planning and resource allocation.
Mr. Dandekar, I'd like you to weigh in on that.
AI is a very crucial catalyst, I would say, for greener data centers. It will help efficiently optimize energy usage, be it cooling systems, be it IT infra like servers or anything, and resource allocation, all to ultimately minimize the environment impact footprint. So by combining automation, AI, and analytics in a single platform, and there are ways to do it, there are tools to do it. You get software assistance, you get IBMS tools, all these integration tools where automation, AI, analytics are brought on a single platform. Organizations have tremendous data that they have gathered, captured through the years of experience that they have run and operated data centers. So all that data is to be used for running analytics, driving machine learning or self-learning of the systems. This will empower better decision making and proactive issue resolution. So whole thing will go from reactive basis, response basis to predictive basis, and that is what will make the difference. Avoidance of inefficiency instances and thereby say directly enhancing data center power and performance efficiency will be the end goal. That is what will happen. Traditional methods often use excessive power, but AI algorithms can change that game. I think by continuously analyzing the temperature controls, adopting the real-time AI significant, AI-driven tools, we can reduce energy consumption in cooling, thereby boosting efficiency. Reducing environmental impact is a no-go, and AI will be a boon in that. According to, I remember one of the Big Four's report I have read very recently, and they have given a very good illustration as to how they are saying this. Any data center company can save up to 40% of its power that goes in cooling by applying AI intelligently, which is huge, which is tremendous. So predictive analysis, anomaly detection, fault prevention, this will play a key role. So they will mitigate issues like via automated actions, preventing temperature rises, cooling related controls from causing interruptions and downtimes. So it will not only drive the power usage to shrink, water usage to shrink, it will also enhance uptime. It will, like we said, it will become more predictive than responsive. AI's capabilities also extend beyond energy efficiency to system maintenance. By leveraging the vast data sets, we said some time back that all the data centers who have been operating setups for ages and decades have huge data, have huge experience, which can be fed to AI, and the systems will become self-learning. So AI will predict potential equipment failures before they happen. This predictive approach allows data center operators to schedule, let's say, maintenance tasks more strategically, minimizing downtime, minimizing energy repairs. Overworking systems provide a big risk, even in case of servers. So AI can help your servers also run more efficiently, avoid excessive resource burning. Systems with AI will provide finer and deeper insights. They integrate observability, the metrics of logs and traces.
So, Timmy, has the AI wave hit Southeast Asia yet? And if not, when's it going to hit?
The AI wave is coming. It's not here yet. So historically, we do see there's a 18 months to 36 months lag behind the US. So US had a big AI boom last year. So I think for Asia, we'll see the boom coming maybe end of this year and early next year. And suddenly we'll all have to change our old ways of thinking, that everything will become liquid cooling, or everything will become the next generation AI data center instead of the current one that we still very much rely on air cooling.
Well, it's really clear that that AI is going to have a big impact not only in Southeast Asia but across the planet. I think as we see the learning models and the inference models roll out. It's been a really insightful podcast, and I just want to take the moment to thank our guests over again, and also to thank Deborah for having me on. I've enjoyed it. Thanks, Deborah.
Thank you so much, Daryl. Once again, we thank our sponsors, Sejori Week and Japan Digital Infrastructure Week. Our next episode will delve deeper into the mysterious world of artificial intelligence and also take a closer look at its impact on cloud infrastructure. If you liked our show or if you have questions or feedback, do write to us at editor@w.media. Bye for now. See you in 2 weeks. Bye bye.